Let me show you what I'm working on here. I've been considering a single stage phono preamplifier design for some time as an economical phono stage, and I've had a few ideas in developing this thing, but I finally put it together for the first time to make a very simple single channel electronic prototype on the test bench this rather dull grey January afternoon. And I wanted to see if I could build a phono preamplifier with modern amplifier ICs that could handle an unregulated power supply, which is a rather dubious preposition for any amplifier circuit that needs to have 60 decibels or 1000 times gain or more at 50 Hertz, the main frequency in this country. And I wanted to use an unregulated supply for a couple of reasons. Firstly, it's tremendously efficient in terms of components. There's not really much there to start inflating the cost. And of course, we only need to add an external linear AC adapter to generate our supply rails. And also, with an unregulated power supply, you've only got capacitors between the voltage rails and the ground. You haven't got any voltage regulator ICs like these, and these voltage regulator ICs consume about 10 milliamps current apiece, going from the regulator input down to ground. So they consume about maybe 200 milliwatts each just to idle. And with this power supply, you haven't got any of that. And when you've got two linear regulators, you've got 2 times 200 milliwatts, 400 milliwatts power consumption, which starts to suggest that you need to have the thing with the option of powering it down after the user's finished using it so as to save power. With this, it doesn't consume any power when powered up, at least not the power supply circuit. This consumes about 200 milliwatts, and this single stage design here consumes about, I'd say, 200 milliwatts, maybe 150 milliwatts, depending on the conditions. Probably 150 milliwatts when there's no audio running through it. So this whole system here can consume, say, maybe less than 400 milliwatts in total, which is enough to preclude the option of adding an on switch. And when you preclude that option, you of course save money in terms of the actual switch, which will probably cost about maybe 60 pence or so. That adds up. And also the muting circuit, because of course when you're switching your preamplifier on and off, you need to add a muting circuit to stop those unpleasant thumps and bangs coming through the loudspeaker as it switches on. And that means, a few transistors, a few resistors, and an expensive relay, which is something that we don't want for an economical single stage design. So now that we've got our preamplifier powered on all the time, what can we do in a single stage? And you might be surprised. I have worked out a way of adding a second order subsonic filter on the front end, not as effective as a third one, definitely, but definitely much better than nothing, and very, very usable in most setups to get rid of that unpleasant subsonic disturbance that you get from the surface imperfections of records, which is very, very important if you're listening through anything except sealed speakers, which prevent the driver from over excursion at low frequencies. So that goes on the front end here, and I just wanted to build it really just to see how it interacts with the power supply rejection of the amplifier IC here, because of course when we run it from an unregulated supply, the amplifier input currents might be modulated by the power supply, and of course if you've got a high impedance filtering network on the input, then that can potentially generate problems with hum. And I have managed to fiddle my values to such an extent to strike a very, very usable compromise to keep hum below 60 decibels of the output, which is pretty good. And of course, with a bit more optimization, it's probably going to be even less. It's very, very difficult to measure it below 70 in my setup in any case, just because, you've got such a sensitive input here. So that's the subsonic filter, and of course, the amplifier IC itself. Now, this isn't an NE5532, this is a 2068 amplifier. And people have found that this produces quite a lot of distortion at high frequencies if you're not very, very careful with the loading. But I have tuned my RIAA network so that it doesn't excessively load the amplifier's output, particularly at the crucial HF. And this has led, surprise, surprise, here we go, what do you reckon? 0.0009% THD at 10 kilohertz at almost 8 volts RMS output, which is quite spectacular. And also in terms of RIA accuracy, if we hand select these capacitors here, which are quite inexpensive, I've only used polyester caps for my prototype here and even managed to get that distortion. I'm sure it's going to be less if we use some high quality polypropylene. Apologies for the shaking hands, I'm just slightly off balance holding the camera at this angle. But I'm sure we can probably get this thing to do RIAA to 0.25 decibels. There's no reason why not. This is just one channel, I'm sure, of the IC. I've just blanked this side off, but you can make a whole amplifier with just this one IC using this topology with a subsonic filter on the input. Very, very useful. And so if we reduce the frequency down, I'll show you it still holds a very good distortion performance. Hopefully you can see what's going on. 60 millivolts, 1005 hertz, and we get, that's not good, is it? What's going on here? Come on, switch on. Blah, 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 blah. It always happens when you're trying to do something. There we go. So, channel A, gain, I'll cut this bit out, no I probably won't. But we've got an RMS output of 5 volts RMS, this distortion analyzer can be a bit funny sometimes, 5 volts RMS, and only 0.000, about 0.0004 THD, so it's still very, very good. It's not just a fluke at 10 kilohertz. So I think we're definitely going to have to make this into a classic audio product now. I'm somewhat a bit disappointed that it's so good because it does come quite close to the performance of the Spartan 10, but of course it's going to be much, much lower cost. All it's going to be is a slightly smaller enclosure than this with a little mono switch on the front and the power on indicator LED, and that will be it. So you'll have a complete phonostage with a subsonic filter, 0.25 RIA accuracy, fully linear split power supply, which is always important. Even though it's unregulated, it's still very much a split power supply with all of the advantages of a split power supply, and we can probably do this for about £150. I'm very, very confident about that. So you can get, you know, a handmade, all through hole, British-made product for the price of Cambridge Audio's phonostage. And I'm pretty sure I can beat them in distortion and probably RIAA accuracy. If I remember correctly, they're only about 0.3 dB. I reckon I can do 0.25, which is marginally better. So that's what I've been up to today. All fun and games. I will develop this thing as quickly as possible now because I'm very, very surprised at how good it is. I really have no excuse not to work on this. So I'll get on with the next batch of Spartan 10s over there, and then I will crack on and develop this thing as quickly as I can, because it would be great to actually get this working in a setup and see if it sounds as good as its spec indicates that it does. There's certainly no reason why not. Very, very pleased with this. Anyway, everyone, you all take care, and thank you for watching this video and subscribing to the Facebook page and so on and so forth, platitudes and extolling the virtues and etc. I've run out of words. Take care.